Hello, all my wonderful students. I'm sorry that I could not be in class with you today, but I'm going to walk through all of your notes so that hopefully you'll feel like you haven't missed anything by me not being there today. All right, so first of all, let's start with the explore and reason part up here at the top. It says consider the function where the areas of the table are doubled. Write an equation that represents this function. Okay. So the area is doubled. So I'm just going to write 2 times the area of x. That's just your typical function notation, so 2 times. Okay? So if this were f of x, let's just kind of look at a pattern here. We have 2. We have 8, because all I'm doing is just doubling the area. So 2 times 1, 4 times 2. 9 times 2 is 18, and then 32 is 16 times 2. Okay, so if you're looking at these values, their pattern just goes 1 squared, 2 squared, 3 squared, 4 squared. So we can say that the function that we're talking about is going to be x squared, but it says double that area, so twice as much. So I'll just put a little 2 out front, and that will perform the function that I'm looking for. Next thing it says is graph the ordered pairs for both a of x and your new function, and how would you describe that graph? So first thing I would do is I would probably use Desmos to try and do my graph, just so that I had a good picture of it. So why don't you go ahead and type that into Desmos. Pause here, go do that. So the first function you're going to put in is this one. And then the second one you're going to put in is that doubled function. Okay, and then it says, how would you describe the differences? So if you're looking at this graph, hopefully you have gone to Desmos and done it. Here's your original. So that would just be my a of x graph right there. And what you should see is that your 2 times 1 is a little taller and a little skinnier because it's going up a little bit faster. So that would be your f of x, which would be 2 times as big, but it's not going to be a huge difference. So you should notice that the f of x points are closer to the y-axis, hopefully. You should notice that each y value in the new function, so f of x, is twice the y value of the original a of x. You might even notice and might even use the terms that f of x is vertically stretched. So all of those are things you should notice. Now, remember that this is going to be a little bit of review, so it should feel very familiar. So let's take a look at this concept. It says a function is a quadratic if it can be written in the form ax squared plus bx plus c, where a cannot be 0, which means that the middle term could be missing, the last term could be missing, or, like we saw right up here, the only term you have is the ax squared. So you don't have to have the bx and you don't have to have the c. All quadratic functions are transformations of a parent function, graphed over here, which is f of x equals x squared. This graph, in addition to being called a quadratic, is also called a parabola. The vertex form of this function is f of x equals a, parentheses x minus h, close parentheses squared, plus k, where hk is the vertex of the parabola. vertex form is useful because it highlights the vertex of the graph in the quadratic function. So when you look at this graph, right, or this equation, you can't just look at it and know what the vertex is. On the other hand, when you look at vertex form, h comma k is your vertex. So each form has its nice options. So let's flip over to the other side to example 1. So example 1 is going to be transformations of a quadratic function. So stuff I want to remind you of, let's talk about what this a does. So a over here determines the direction, and it also determines if the graph is stretched or compressed. So it determines the direction, and if the graph is stretched or compressed. Okay, our next letter we're going to look at is the H. So the H determines the horizontal translation. What happens with this horizontal translation is the opposite of what you see because of the minus sign that's in the formula. So if you put a 2 in here, it's going to look like -2, which makes it seem as if it is moving to the left 2, but it will actually be to the right 2. And then over here, this very last value, this is your vertical translation. Okay, this one is exactly what you see. So if you see a +3, it's up 3. If you see a -3, it's down 3. So let's take a look at 4 examples and figure out what all is going on. So there is a lot happening in this -1/2. So first of all, there's a negative. The negative causes it to reflect across the x-axis. Next, you have a 1/2. A 1/2 causes it to compress vertically. It's half as tall. Then you have a horizontal shift. Remember, it's the opposite of what you see, so it'll be going left 2. And that's it. Let's try another one. Let's take a look at B. So with B, you have a 2 there that causes a vertical stretch. Then you have a -1, so that's going to be going right 1. Opposite of what you see due to the minus sign that's in the formula. And then we have a down 3. So we have that vertical shift down 3. Okay, let's try another one. So that is a 0.4. I recommend that you rewrite that as a fraction just to kind of see what's going on. So that is just like the fraction that we had up above, only it is positive. So that means that this is going to do a vertical compression. Anytime the number that is A is between 0 and 1, I'm not talking about negative, we're talking about fractional or decimal. it's going to be a vertical compression. Then you have a shift inside the parentheses, means it's horizontal, always opposite of what you see. So that'll be right 3. Moving over to this side, we have a 3 here. That is going to cause a vertical stretch. Then you have that -1 inside the parentheses, so that's horizontal, opposite of what you see. So it's right 1. And then finally we have a vertical change, and that is going to go up 2. So that's just looking at already written equations and figuring out what is going on with those pictures. With those equations. Now let's slide down to a picture. So we have the function. It's a little weird the way it's written, so I'm just going to kind of shift that over here just to make it a little clearer. So there's my function. There is the equation of that function. So let's take a look at it and let's see if all this makes sense. So here's what I expect when I see this. This is a vertical stretch. When I look at the picture, I should see it kind of a little skinnier than I expect, because if I were graphing this going from the origin, I would expect these to be a little bit different than they are. All right, then we have opposite of what we see, horizontal, so that'll be right 3. And then finally, we have that vertical translation, so it's going to be up 4. Now, let's take a look at our graph. So here's where we would have started if we had no shifting. As you can see, it has been moved to the 3, up right 3, and then it has gone up 4. We would expect our graph to be a little bit wider than this one, and ours is a little skinnier just because of that vertical stretch. Okay, last thing on this, do want to point out that your vertex is h comma k, 3 comma 4, and the axis of symmetry always goes to the x coordinate of the vertex, so it's x equals 3. Okay, now let's go down to this one. Again, I want to remind you, you do have the option of using a graphing calculator. I'm just going to do a really rough sketch over here. Okay, I'm not going to use it, but I do want to remind you, you do have that option. If you wanted to type it into your calculator, you certainly could. First thing, make sure that that plot is off, because we were using it in the last unit. So we want to do that. If you can't figure out how to turn stuff off and you just want to reset it, you can flip over the skinny calculators and you can just put your pencil in that little hole till it resets. So you can just come up here and you can just type your equation in. So it'd be negative, let's see, there's my variable x plus 4 squared minus 5. You could also go to Desmos. I want to do my graph. As you can see, my graph doesn't look right, so I'm going to zoom 6 on my graph, and hopefully I will get to see something. There it is. Okay, so here's my picture. Let's see what it's going to look like. So that negative causes a reflection. Across the x-axis, meaning instead of going up, it's going to go down. Opposite of YC, so it's left 4. And that's down 5. Okay, so let's make that graph. So normally my graph would start at the origin, but I'm going to go 1, 2, 3, 4. 1, 2, 3, 4, 5. So there's my vertex, which should be at -4, -5. And I know I reflect, so I'm just going to reflect downward. So there's my rough sketch, super rough. Let's do our vertex. So first of all, the vertex, That's my h comma k, opposite of what I see there, so -4 comma -5. Next, axis of symmetry. Axis of symmetry is super simple. It's just x equals the x coordinate of the vertex, because your axis of symmetry just splits your graph in half. Normally we write AOS for axis of symmetry. Minimum or maximum. So it says minimum or maximum because you only have one of those. If your graph points down, you have a maximum. And that's at the vertex. Now let's talk about the harder one, domain and range. So for every single quadratic that we ever have, the domain is the same. The domain is -infinity to +infinity. That means you quite literally can put in any x value and it will always produce a y value. Now let's talk about the range. The range is a little bit harder. So if your graph turns upward, you start at the vertex y coordinate and you go up. But this one goes down. So if I write it this way, yes, I know this is wrong, class. Just look, don't write. This graph starts at the y value because range is y and it goes down. But I can't leave my answer looking like that because the smaller numbers are always supposed to be on the left and the bigger numbers on the right. So you can't write it that way. You have to do -infinity to -5. Now, are we actually equal to 5? Absolutely, so we're going to put a bracket. And that's what range looks like. Hopefully that's familiar. Okay, so if you are a person who is watching this over 2 days, you could stop there, or you can just keep going and watch it all on day 1, fill in your notes, and then on day 2, do all the homework. It's up to you. So the next part says write the equation of the parabola. So what is the equation of a quadratic function with a vertex of -2, 3 and a y-intercept of -1? So that point is 0, -1. Y-intercepts are always 0, whatever the y-intercept is. Okay, so here are my 3 steps. Don't worry, I'll do it again in case you missed it. So first of all, substitute the coordinates of the vertex for h and k in the vertex form of the equation. Okay. Now the formula has a minus, so I have to put in a minus there, and then I pop in the -2. Don't forget the square. That's a pretty common error. And I'm going to clean up that double negative because I really shouldn't leave a double negative like that. Okay, so I've gotten to there. Next thing, substitute the values of x and y for the y-intercept. So I wrote that down as a point for a reason. That's my x, that's my y. So let's do a little substituting. All right, now we're going to use our algebra to solve for a. So cleaning up some more, simplifying. 0 plus 2 is 2 squared. Yes, I'm showing all the steps. If you can do this a little faster, you're of course welcome to do so. Subtract the 3 to the other side. And divide by 4 and you get a equals -1. Now you're going to go back to this step 1 that you have here, that equation right there, and you're going to substitute the value of a into the vertex form of the quadratic. Now you'll notice I'm putting the y back in. And that's my answer. I can also simplify this a little bit if I prefer it to look like this. So that's my process. Step 1, substitute the h and k in. Step 2, substitute the x and y. Step 3, put the x and the y back in and replace the a. So hopefully that went super well for everybody. Okay, let's try another one. So be careful, that's your vertex. So step 1, is to substitute the vertex into the equation. Don't forget the square. Okay, step 2, you're going to take this other point. Now, last time I gave you the y-intercept, this time you've got to use that other point, so let's do that. So that's your x and that's your y. Be careful about your signs. Very easy to mess them up. Now let's do a little bit of simplifying and solve for a. Okay, move the 4 to the other side. Now when you divide by 9, you're going to get 3 over 9, not 9 over 3. So the answer is not 3, it's 1/3 is equal to a. So be careful about that. You're dividing 9 on both sides, not dividing the other way. So you end up with 1/3. And then step 3, you're going to resubstitute into this equation, the step 1 equation, and you're going to put the a in. And that's your equation. That's your answer. Let's do it one more time. Okay. Step 1, substitute in your vertex. Watch out for that double negative. Very easy to mess up. Let's clean it up just a little bit. Okay, step 2, substitute in the point. Okay, now you have to use your amazing algebra skills. So let's work through that. So that's 2 squared. I'm going to skip that one step and just go ahead and call it 4. Again, that's 2 squared. Okay, move the 4 to the other side. That'll be -2. And remember, you're dividing by 4, which will give you a fraction. You're not dividing by -2. Okay, step 3, take that a, substitute it back into equation 1. Okay, so we did that 3 times in a row. Hopefully one of those connected for you. Now let's see one that's an application, but still doing the same stuff. So first of all, you should be able to just look at this equation and find your vertex. So your vertex is your highest point. If you come over, again, watch out for the scaling. Your time is 1 second and your height is 20 feet. Okay, now you should be able to find another point on the picture, but my favorite point, if you can see it, is the y-intercept. So this coordinate is over 0, up 4. So this is going to feel a lot like that very first problem that we did. So let's take all of this and let's write the equation. So step 1, fill in the equation with what you know. We're putting in that vertex first, in case you're a little bit lost. So we start there. Step 2, we're going to put in that other point, which in this case is a y-intercept. Okay, I wrote the wrong number. Let's fix that. Okay. Okay, let's solve. So I've got 4 equals a. That's -1 squared, so that's just going to be 1 plus 20. So I'm going to pull that 20 to the other side. I get -16 equals a. All right, so now we're going to take this a, put it back into equation 1. So my equation is y equals negative 16 x minus 1 squared plus 20. So notice how it's just using the exact same process. Now the last thing says put this into the other form. So you're just going to have to do some algebra on this. So this form that's right here, that's a vertex form. Let's put it into standard form. So standard form is just a matter of doing algebra. So the first thing I'm going to do is expand this. Okay, I'm going to FOIL the two parentheses together. So I'm putting these guys together. I'm going to multiply that first before I distribute the 16, because the 16 just makes everything get big. So that is going to be x squared minus 2x plus 1. I'm now going to distribute the negative 16. And now that I have all that done, all I have to do left is combine those like terms, and then I'll be in standard form. So there is my standard form. Okay, we have a little bit left. We're almost finished. Number 2 is just a repeat of that same type of problem. And yes, of course, I'm going to walk you through it. I like how on example 2, they went ahead and gave you the 2 points so you could see them. But let's go through our process. Very first step, write the equation with the vertex filled in. Step 2, substitute in the point they gave you right there for your x and your y. Use your algebra to solve for a. Okay, so that number that I've got in here is negative 2. You square that, you get 4. Move your 10 to the other side. And divide by 4. And you're going to end up with negative 3/2 equals your a. So you've gotten to here. It's now time to take this a and substitute it into equation 1. So we now have our equation in vertex form. So this is vertex form. This is vertex form. Vertex form has parentheses. So now we're going to take it and we're going to multiply it out and get rid of the parentheses. Let's do that together, and this will be standard. Okay, so I'm going to start by expanding that parenthesis, writing it twice, so I'm ready to FOIL it. I'm now going to FOIL the 2 parentheses. Do not distribute the negative 3/2 until after you FOILed it. There's no need to make this problem super hard. So I end up with x squared. I have 2 negative 2x's, which gives me negative 4x. And then the last parentheses together come together to be 4. Now distribute your negative 3/2. If you need to use a calculator to help you, please do that. Like if you don't know where that 6 came from, type in negative 3/2 times negative 4 and you will get positive 6. Last step, put those two pieces together. And now you're in standard form. So that's vertex form with parentheses, standard form, no parentheses, all multiplied out. Hopefully that went super, super well for you. We have one last type of problem, and we'll do a couple of those just to make sure you've got the hang of what's going on with it. It says a function g is a translation of the parent function if it's moved 1 left and 3 units up. What is the equation of g? Write the quadratic equation in vertex form and in standard form. Okay, so first thing I'm going to do is do g of x. Now they did not specify any kind of a stretch, shrink, or reflection, so I may assume that a is 0 in the case of my vertex form. Actually, I'm sorry, not 0, but 1. So I may assume it is 1 because, again, they did not specify a stretch, a compression, or a reflection. So I'm going to have x. 1 unit to the left means -1, so we'll make that a +1. And then up 3. Remember, what's in the parentheses is always the opposite of what you see. This is vertex form. Now let's FOIL it out and let's put it into standard form. Write the parenthesis twice. That's what the parenthesis means. Sorry, don't want the square there anymore. FOIL it, so it'll be x squared plus 2x plus 1. So that will be x squared plus 2x plus 4. That's standard. So, vertex, standard. Let's do it again. Okay, they said let equation j be a function that has been translated to right, 5 down. Again, no mention of a stretch, a compression, or reflection, so a will be 0. So this will be j of x equals x. If you want to go right 2, you've got to see the opposite there, so -2 squared. And down 5, so -5. That's vertex form. Let's convert it to standard form. Write the parenthesis twice. That's what that square means. And FOIL it out. If you need more time than I am providing to FOIL it out, you know you can hit the pause button. So you don't have to like rush along like I'm doing. You can go, oops, sign error. I know somebody out there's yelling at me going, oh, you messed up your sign. There we go, all fixed. Okay, we have one last example left. This one has been translated down 1. Nothing else, just down 1. That's all. So there's no mention of a horizontal translation. There's no mention of a reflection, a stretch, or a compression. So this time my j of x is going to be, remember a is 1 if you don't have anything, x minus 0 squared minus 1. Let me clean that up a little bit. That's just x squared minus 1. Oh, I see a reflection. So it said reflect the graph. So that means I need a negative and a negative to do the reflection. And we are all done with our notes. You should now be able to do all of the assignment 2.1. But I've just talked for 35 minutes. So you may have reached a point where you're like, dang, I don't really, I can't do all this today. Remember that you have 2 days to do this. So this is not going to be due tomorrow. It's just due the next day after that. I believe this assignment, if you look on the calendar, is due on Tuesday at 7 a.m. So use your class time tomorrow to get all of these problems done that you started on hopefully today. And I will see you all back again on Tuesday. And I hope you have a good long weekend.